So, hi and welcome everybody. In today's part, I will talk about how to build a Wi-Fi network without having interference. How to build such a network in a building, school, university, business, or a company, or wherever you want. So, to make sure that there will be no interference between the access points that you install in a certain area, you need to allocate the spectrum of the Wi-Fi very properly and carefully. So as you know, we have 11 channels in the Wi-Fi spectrum, and this is about, in the case of using Wi-Fi 5 or Wi-Fi 4, it's about 100 megahertz. But due to interference issue, we usually try to pick just 3 channels out of the 11 available channels. And the spectrum bandwidth of each of these channels is about 20 megahertz. So usually we select channel number 1, channel number 6, and channel number 11 because they don't interfere with each other and they don't cause inter-channel interference. So then we go to the area that we want to install our access points on. And for each access point, we assign, let's say we have 2 sides, 1 corridor, 2 sides, the first side representing 3 areas or 3 classrooms, and the other side, the left-hand side is also another area with three rooms or classes, and you install 1 access point in each room or each class to serve the users in that room. So as you can see, we select, for example, the first channel, channel 1, we assign it for access point 1 with 20 megahertz of spectrum, and channel 6 for access point number 2 with 20 megahertz of spectrum, and channel 11 for access point 3. Now, this is how you should select your access point to make sure there is no interference between them, and you leave some overlap between them here. This is overlap in coverage, not overlap in frequency. You leave this overlap to make sure that the user can move on from one class to another or from one area to another without losing the connection with the internet. So this overlap helps in the handover process. Makes sure that you keep the connectivity while you are walking or moving. And for the other part, as you can see, this is the opposite channel is using this access point 1 is using channel number 1. So the channel, the access point next to it, or the access point opposite to it, should use a spectrum that doesn't interleave or overlap with it, which can be channel 6. And this access point 5 can be assigned channel 11 to make sure there is no interference between them. And access point 6 is very far away from access point 1. We repeat using the same spectrum as access point 1, which is channel 1. And then in a wired network, usually what you do, you connect all these, each one of these access points with an Ethernet cable, and you take it to the switch, a switch device which can have usually 12 or 24 ports over Ethernet. 24 ports Ethernet, and they have power also. They provide power and data for the access point. And this switch can be connected to the router, and the router can be connected to the Internet service provider. And of course, you can configure all these access points by connecting through the switch, assigning the power of each access points, the channels, the encryption, the decryption, the SSI number, the password, the authentication type, and the encryption, and all these details. You can configure them remotely from the laptop that's connected to the switch. And all these lines are Ethernet cables that have power and data. So this is how you build a network, but in case you don't want to build the network using Ethernet cables, but rather using wireless connectivity, in that case you need two wireless interfaces, one for serving the users in the area and one for backhauling. So instead of using Ethernet, we use another, let's say, another wireless link that could be Wi-Fi with beamforming, and can be these ports will be also connected with Wi-Fi backhauling access point, and they can be connected they can be connected with each other instead of using the Ethernet. So there are important points that I need to mention here, that the design, such a design ensures having no ICI, no inter-channel interference, and no co-channel interference between the access point. Now, although the channels, they may seem that they are overlapped in coverage, but they don't interfere with each other because they don't overlap in spectrum. We should note that half of the spectrum in Wi-Fi band, which is in the case of Wi-Fi 4, which is 802.11n, we have about 100 megahertz of spectrum, around 2.4 giga. 1/3 of it is just used for gap bands, which is a wastage to reduce interference. So we have different types of Wi-Fi here. We have Wi-Fi 1, 2, 3 until 4, and this, the technical term, the IEEE technical term for them is 802.11 A, B, G, and N. So this is G and N. And in this technology, we use carrier sense multiple access collision avoidance. We have multiple users connected to the access point. And whenever a user has data, he tries to listen to the channel before he sends his data. If the channel is ideal, means nobody is using it, the user sends its data. But if it's not ideal, if the channel is busy, he will back up a certain window time and try again. So at the end of the day, at a certain time, just one user can access the whole channel and send his data, which can reduce the throughput as you increase the number of users connected to the access point. For Wi-Fi 5, which is the technical term is 802.11 AC, we use not just carrier sense multiple access collision avoidance, but also multi-user MIMO. And we increase the spectrum from 2.4 giga, the frequency that we are operating on, to 5. We use also 5 gigahertz. And therefore, the bandwidth increases from 100 to around 300 megahertz. And then Wi-Fi 6, which is 802.11ax, we use in top of the frequency, the biggest technologies, we use OFDMA, orthogonal frequency division multiple access. And in Wi-Fi 7, we use enhanced OFDMA with much more enhanced multi-user MIMO, where we have 16 streams instead of 8 stream here and 4 streams here. And we have multi-link operation, where you do the aggregation on different bands. Now, these are the important points. Plus, anybody can build a Wi-Fi access point. You don't need to buy it from the market. By using like Raspberry Pi with some open source operating system for building routers like OpenWRT. Long range can be achieved by using Wi-Fi adapters, power amplifiers, or high gain antennas to reach and cover wider areas. In outdoor scenario, if in outdoor scenarios, 4G, 5G network can act like the backbone for the Wi-Fi access point. It can save power at the phones because the phones don't need to transmit too much power to reach the base station, and it can improve the performance in general. So if you have a 4G, 5G tower and you have a router that can be connected to 4G, you use a very high performance antenna to capture the maximum amount of the energy of the 5G base station, and then you convert this into Wi-Fi. And there is power source here which can be connected to a renewable resource. You can also use Wi-Fi as backhaul, point-to-point communication, and then maybe use the 4G, 5G for access, which is doable and possible also. You can also use Wi-Fi to Wi-Fi. So we have 3 cases. We have cellular as backhaul and Wi-Fi as access, or Wi-Fi as backhaul and cellular as access, or Wi-Fi as backhaul and Wi-Fi as access, Wi-Fi to Wi-Fi, or cellular to cellular, cellular for backhaul and cellular for access. So thank you.